Well, good day. This video is about section 1.8, which deals with exponents and the order of operations. It's sort of the last of our basic reminder topics of things we need to remember as we head into beginning algebra. We're going to start off by defining what an exponent is, and then we're going to evaluate those expressions. And then we're going to work on simplifying algebraic expressions that have exponents in them. And then we're going to talk about order of operations and how we would do those in problems and some of the pitfalls and so forth where we can get stuck. All right? So let's get started right now. Next slide. So what's an exponent? An exponent is a notation that we use to indicate or for repeated multiplication. So if you'll remember, if we have something like 3 plus 3 plus 3 plus 3 plus 3, where we have a repeated addition, because we're doing that 5 times, we can shorten this notation by writing 5 times 3. All right? And that's what multiplication is. It's repeated addition, and it's a shortcut to write repeated addition. So what if we have repeated multiplication? 3 times 3 times 3 times 3 times 3. Again, we're multiplying 5 times. How do we write that? Well, we would say 3, we're taking the 3, and we're multiplying it by itself 5 times. And we would create what is called an exponent. Okay? And then the 3 would be called the base of the exponential expression. Okay? Sometimes we refer to exponents by the word power or powers. Okay? And so this would be like 3 to the 5th power. Okay? Or just 3 to the 5th. Okay? Either one of those are fine. If you multiply something by itself just 2 times, for instance, 3 to the 2nd power, we often say that that is 3 squared. Okay? All second powers can be referred to as squared. All third powers can be referred to as cubed, and so forth. So let's just look at a couple of simple simplification problems. So some quick problems would be like these. You might see something like negative 4 squared, which means negative 4 times negative 4. Okay? So that would be a positive 16. Now, you don't always have to write this out. You can just multiply it in your head. But writing it out may help you avoid negative sign mistakes, things like that. You might have something like a negative 5 cubed, like this. And so that would be negative 5 times negative 5 times negative 5. Which is negative 125. And so fairly straightforward to remember this. Now, of course, you can have like 10 squared, which is 100. Positives are fine. I want you to notice whether you have a negative in parentheses or a negative not listed in parentheses. This is one issue that causes students mistakes. So what if I have negative 4 squared like that, and I have negative 4 squared like this? If you want the negative sign repeated, you write it like this. Okay, whoops, times negative 4. There we go. You write it like this if you want the negative sign repeated. if you want the negative of something squared, in other words, the opposite of 4 squared, that's this one here on the left. And that would be the opposite of 4 times 4. Now, you have to understand that this negative here is understood to be like this, the negative of 4 squared, where the exponent is inside the parentheses and the negative is outside the exponent. And that's why we write it like this. So this one's going to be a negative 16. This is a very common issue and something where students make mistakes all the time. So you got to it's a common negative sign mistake, and how you enter it is very important, okay? Even if you're just punching it on a calculator. Okay, let's move on to the next topic. So here's a couple of problems to try. Pause your video, try each one of them, and then come back. Okay, I guess you're back. So let's look. 6 squared, it's equal to 6 times 6, which is 36. All right. A negative 4 cubed. Notice the negatives in the parentheses, so we're cubing the negative as well. So it's negative 4 times negative 4 times negative 4, which will be a negative 64. Okay. Negative 2 to the 4th. The negative is outside a pair of understood parentheses. So we're taking the opposite of 2 to the 4th. So the opposite of 2 times 2 times 2 times 2, or a negative 16. So always watch out for those negatives that are understood to be outside a set of parentheses. Okay. So of course, once we introduce exponents, just like addition, subtraction, multiplication, and division, you would find exponents showing up in algebraic expressions. And so for instance, we're going to need to simplify algebraic expressions that have exponents, all right? And these expressions are going to look something like this. What if we had a negative 8x squared plus 3x squared? Okay. Now, we need to define what like terms are a little better. A like term is going to be a term in an algebraic expression where the variable and the exponent parts are exactly the same. Now, as you can see, both of these are x squared, so they are a like term. So we could go ahead and add the coefficients and get negative 5x squared. Now, what happens is when sometimes students will see like 7x squared plus 2x minus 3 plus x squared minus 4x plus 1, something like that. And you want to simplify that algebraic expression. And what happens is when students see all the x's, they just combine all those. And that's not correct. If you were multiplying, then you would have an x times an x squared, and you would add exponents. And that's going to come a little later. We'll talk about that. And in this expression, we just want to recognize that the x squareds are one type of term, the x's are another type of term, and then the constants are, I probably should have done a diamond or something around those. The constants are another type of term. And so there are three different sets of like terms here. And so we just want to visually be able to catch that. Now, that's not going to happen much in this assignment, but it will happen in some later assignments. I just wanted you to be aware of that. Okay? Most of our problems are going to be just like this, fairly straightforward. Okay? That then takes us to the next topic, which is order of operations. So I want to discuss these just a little bit philosophically. Most of you have all heard of either GEMS or PEMDAS or some other method of remembering how to do this. And I tend to use PEMDAS when I think about it, but what I want to talk about is, why do we have an order? Where did the order come from? Why did it show up? And I think if you think about it this way, addition, okay? That's the most basic operation. There's addition, and then we come up with subtraction. But when we define subtraction, we found out that subtraction is really addition of the opposite. So it's really addition as well. So that's the reason why we say addition and subtraction. They're equal. They're exactly the same type of operation. They're both addition really in disguise. And so, and addition's the most basic thing. It's the thing we do last in some sense. Now, why would we do it last? Well, what is multiplication? First of all, multiplication is repeated addition. So if you were to have 3 plus 3 plus 3 plus 3 plus 3 and change that to 5 times 3, what you're doing is you're making the hierarchy, you're saying this is a repeated addition, so we're going to do all of them first before then we might add the 7 to the 3. And so what you would tend to do is you would tend to add up all of those first by simplifying it to a multiplication problem and then choosing to do the multiplication. All right? So repeated addition leads to this idea of multiplication. So that's why, and then of course division is just multiplication by reciprocals, so they're really the same thing. They're both multiplication. So that's why we do multiplication and division before we do addition and subtraction, because of their repeated nature. All right? And that's why we would do that before. And then we're kind of adding the singletons on at that point. So then that takes us to exponents, okay? As you have seen just by writing things like this, exponents kind of have a parentheses effect. All right, we either have a parenthesis around the -2, so we're saying take it to the 4th power, which is a multiplication, right? But it's repeated multiplication, so just like multiplication was repeated addition, repeated multiplication should come before just multiplying any two numbers. And that's why we do exponents, all right? Now, exponents have these sort of understood parentheses in this case. Fractions have understood parentheses, the numerator and denominators. You know, you got to do all the arithmetic in the numerator or denominator to get one fraction. And so parentheses are sort of an indication of always do this first. And so that's kind of where it came from. And I'm not sure if you've ever been told that before, but Hopefully that helps a little. And that's why we do it that way. Okay? Now, we also, in mathematics, we work from left to right. All right? When doing an operation. So when we do parentheses, we'll do the parentheses, we do, I should say, inside out. We do the inside most ones first and then the outside parentheses. But then all the work we do inside the parentheses, when we're actually adding and subtracting or multiplying and dividing, we do those things from left to right. Okay? And so let's look at a few problems and see how we can do these. And I've had students who've really struggled with this. And so it's fairly important that you make sure you get this down if you haven't had it down in the past. Okay, so let's go to problems. We've talked about the why, so let's do problems now. Okay, there's our first problem. I guess I didn't turn off my audio there and I just wrote it. So anyway, there's our first problem. So when I look at this, I see some sets of parentheses. I'm just doing the parenthesis thing. And that means I want to do the arithmetic inside the parentheses first. So what I do is I write down essentially everything outside the parentheses. Okay? Everything outside. I just rewrite that, and then I do what's inside. So 3 minus 5 is a negative 2. And 1 minus 3 is a negative 2. Now, this parenthesis up here, just so you know, it's a separator, but it also has arithmetic inside. That's why we do what's inside first. This parenthesis down here is just a separator. We've already done the arithmetic. Now we have negative 2 to the third power. So we're actually taking the negative to the third power. That's why I left the parentheses there. Okay? Just to separate it. All right? So now we go on. Now the next thing we do is the exponent. We have two exponents, so we're going to do the one on the left first, then the one on the right. That's going left to right. And so the 6, and then that's going to be multiplied times negative 2 cubed, which is negative 2 times negative 2 times negative 2, or negative 8. And then I have minus 2 times another negative 8 here. And there's the exponents. So now all I see are multiplications and a subtraction. So I'm going to do the multiplication division steps now. 6 times negative 8, this is the leftmost one, negative 48. And then negative 2 times negative 8 is positive 16. Okay? And now I can do the additions and subtractions. That's what's left, negative 32. Okay? And so I just go one step at a time. And I always say it makes a really nice right triangle when you do this. If you keep the work organized and work your way down. Okay? So now let's move on to a slightly more difficult problem. This one, whoops. This one here, sorry, I had a little camera issue there. This one here is going to be a little bit different. I want to do like, let's do this. negative 11 times negative 4 plus 2 times negative 7 divided by 7 minus negative 3. Okay, I picked this problem because it's a fraction. And I want to talk about fractions really quickly. In fractions, they never draw them, but a fraction has parentheses around its whole numerator and its whole denominator. I call them understood parentheses. And understood parentheses show up in a lot of mathematical symbols, okay? Like fractions. The numerator and the denominator are separated. They each have a set of parentheses around them. Understood parentheses also show up in square roots or any root. Anything under the square root is actually in a set of parentheses. So whatever's under the square root, or if you wish, you can imagine that the square root is a separator all its own. So you have to do what's under the square root. And then things inside functions and stuff like that are also the same thing. So let's go ahead and do this problem. Because I put in the green parentheses, that means I do the numerator separately and the denominator separately first. So first step, negative 11, this I have only multiplications and additions, so I do the multiplications. Negative 11 times negative 4 is 44, plus 2 times negative 7, which is minus 14. So I'm leaving the parentheses there. Now I'll do the denominator. 7 minus a negative 3, add the opposite, that's plus 3, so that's a 10. Okay? Now, since I have a single number in the denominator, I am done with the denominator. And I move to the numerator. 44 minus 14 is 30. And that gives me 3. Okay? 30 divided by 10. And now I'm done. Now notice, within the parentheses, I follow the order of operations. And then when I'm done, now I've still got a division to do. Okay? So it feels like division was after addition and subtraction, but no, each set of parentheses is like an individual problem on its own. So you do all those, and now you have a whole new problem when we get to here. Okay? And that's why you don't need to be confused by that, but why some people might be. All right, let's do one more. Okay. Here's one more. And in this case, as you can see, I have a fraction here. So, and that numerator it's got some operations, so that's a set of parentheses. So that's what I need to do first, is that numerator. So I do that. Now, I'm going to show you something that I often do. That numerator is fraction work. It's 7/9 minus 3. So on my scratch paper, right next to the problem, not somewhere else, right next to the problem, I'm going to do the work required for that part. So 7/9 minus 27/9. So what I did is I multiplied 3 by 9/9, so I'd have a common denominator. So the numerator is negative 29. So now I've done that operation. So now I'm rewriting negative 29 divided by 5/6 plus 3/2 plus 3/4. Okay. Now I have a division, fraction divided by a fraction, plus plus. So I'm going to rewrite that division as multiplication, because that's what I do with fractions, times the reciprocal of the bottom, which is 6/5, plus 3/2, plus 3/4. And now I do the multiplication, and if I felt like I needed to, I would do that over here on scratch paper. In fact, I will. Negative 20/9 times 6/5. So 5 goes into 5 one time, and into negative 20 it goes negative 4. And then 3 goes into 6 2, and into 9 3 times. So I had a little canceling I could do there. So it's negative 4 times 2 and 3 times 1 is negative 8 over 3 plus 3/2 plus 3/4. And now I can finish the problem. It's all addition. So I need a common denominator between 3, 2, and 4, which is 12. So I'm going to write all of these over 12. All right. And I know most of these. And how you could do that, since I want 12, I multiply this one by 4 over 4. I multiply this one by 6 over 6. And I multiply this one by 3 over 3. And that's how I got the numerators. And then I would just finish. I could add the numerators. So that negative 32 plus 18 is negative 14, plus 9 is negative 5/12. All right. And there's your order of operations. I would say I just did this problem. It's one I got from the book. And the answer is wrong compared to the book. All right. And so this is what one of the things I want to show you. It's pretty easy to make a mistake. I don't think I did anything wrong here. I showed all the work correctly. And so I'm thinking the mistake I made is I copied wrong, and that is true. Right there, that is actually a division symbol. It's supposed to be a divide and not an addition. So that would actually change my order of operations, and I would end up getting a different answer. Now, the fraction work here that I did right here and here would not change. What would change is after I got the negative 8/3, I would multiply by 2/3 and get negative 16/9 plus 3/4. So the problem at this step would have been negative 16/9 plus 3/4. And I would have had a different common denominator, so negative 64 over 36 plus 48 over 36, which would have been a negative 16 over 36. And then I would have had to reduce that to negative 4/9. All right. And so that's the kind of issue you have to watch out for if you make a mistake. All right. And so in this case, my only error was I saw it as an addition, not a division right there. I have old eyes, so I have to look very closely when they write those divisions with the 2 dots. Otherwise, I'll make a mistake. But wanted to talk to you about that. Now, the other thing I would say about that is if that was a division, that's the second division because this one's first. And so you do this division first, then that one's second. Okay? Anyway, I hope that helps. and it shows you that it's fairly easy to make an error just by copying things wrong. So always double check, unlike me. All right. There are two other problems I just noticed. They do some evaluation problems in this assignment. So they give you something like x squared minus 2x, and then they tell you x equals 6. So you would substitute and get 6 squared minus 2 times 6. So this becomes an order of operations problem. That's why they're asking you to evaluate. So you get 36 minus 12 or 24. Okay? That's a typical evaluation problem. And then the other ones is they had some simplifies that look more like order of operation problems. So the one I want to write of those would be this one. Let's go with 6 minus 5 times 8 minus 2y minus 4. All right. So when you see this, this looks like an order of operations. The directions are going to be simplify. Okay. And so we have to follow order of operations when we simplify. And so you want to be careful not to go left to right. Don't do 6 minus 5 first. Look at the problem, say, okay, this is my inside most parentheses, but I can't really add there because they're not like terms. So the next thing I do is I do the multiplication or the distributive property multiplying by the -1. So then the next step would be 6 minus 5, 8, and then -1 times 2y is -2y. -1 times -4 is +4. And I end up there. All right. And then now I have like terms in this set of parentheses. And the only reason they use brackets or braces, those are all just parentheses. They use them just to nest so you can visually separate it. But I've often not made brackets and just like on a calculator, I'll just use regular parentheses and just nest them. There's one set inside and I match up a front and a back together. Anyway, I have like terms here, the constants, the 8 plus the 4. So I'm going to do that, 6 minus 5. And 8 plus 4 is 12. So I have 12 minus 2y. All right. Now, there are no more like terms, so I can now do my distributive property by -5. So I get 6 minus 60, -5 times 12, plus 10y. And then 6 minus 60 is -54 plus 10y. And now there's our right triangle, right? And so I am done when I have no more like terms to collect. So you might have some simplify like this on the assignment as well. Okay? So good luck at this point. Talk to you later. Bye.